Hello everyone, hope you are doing well. Welcome to the online platform Civil Techno Bricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Guys, today we will see the core concepts related to the elements of visual image interpretation and its usage. Here, the visual image interpretation is the process of identifying and analyzing the objects along with the phenomena present in remotely sensed data using their visual characteristics. Here, the data acquisition, which is related to the measurement of electromagnetic energy with reference to the radiance or reflectivity, is collected so that we can use this data collected with reference to the ground control points where the latitude and longitude is noted. It will be used for the human processing so that we get the detection, identification and logic, or we can use that data for our objective solving. Here it utilizes human expertise and experiences basically to recognize the natural and man-made features based on the image appearance. Here that interpretation can be performed on satellite images which are taken by the aerial photogrammetry or aerial vehicles. That aerial photographs and drone images are useful to extract the meaningful information from it, which is also extracted with reference to the layer point of view, that we can also call it as a thematic map or with reference to the intelligence point of view also. So here we do not see the materials directly, we infer their nature from physical measurements. This is the actual interpretation methodology with reference to civil engineering domain. That visual image interpretation supports site investigation, land use planning and route selection with reference to the infrastructural monitoring function. We see the interpretation procedure which is related to the cognitive workflow that explains the actual methodology or the process or flowchart from the detection to the classification. So here we are doing the visual image interpretation based on some parameters or characteristics. So detection, that is the picking out an object, the point or line is something there, just like we are locating the points, just like the location point of view. This is the actual stage 1, which is the initial contact. Stage 2, which is related to the feature assignment, where we have to recognize and identify the object, that this is a stream or this is a house, just like we have to identify which type of object it is. Followed by the stage 3, which is the spatial delineation, where we have to do the analysis, which includes the delineating boundaries and spatial patterns, separating discrete units with reference to the zoning or with reference to the sorting the data or analyzing parameters. After that, at the end, we have the stage 4, which is the final categorization, which is based on some classification tools where we have to assign final categories, just like residential, commercial, non-residential or agricultural or industrial point of view. So here this is the actual imagery taken by the aerial photograph, so that we have to target only that building with reference to the target feature, commercial structure. Likewise, we can use that interpretation procedure for classifying the n number of buildings which are captured with reference to a image. We see the first element, tone or color, that is the fundamental building block or basic or initial building block. With reference to that, two images are there. Comparative analysis, we will see that image which have the exact middle center point where high moisture or wet soil or broad level clumps are captured, which is also a dark tone with reference to that brightness, where high moisture, wet soil is and broad leaf clumps are marked or noted. Here the second image, which is having the light tone, where dry soil, quartz sand and confines are noted. Means we have to compare the two images based on some tone or color point of view that refers to the relative brightness or darkness of an object in a monochromatic image point of view. So here the color represents variations observed in multispectral or any false color composites. That different materials which are encountered in that image, they exhibit distinct tones or colors which are dependent on their reflectance characteristics and moisture conditions. Here the water bodies generally appear dark, vegetative appears bright red in FCC images, false color coding images. But the built up areas show the shades of gray or just like cyan colors. So here the golden rule of interpretation, which should be based on the relative tones, not absolute values. So here the atmospheric haze and sun angle change absolute values which are related to the contrast remains constant, so that civil engineers use that rule with reference to the tone and color point of view or their variations to identify the land cover, reservoirs, roads and urban development zones. Second element, that is the shape, which is related to the geometry reveals function, which is related to the man-made activity or man-made features. They have distinct geometric and finite boundaries just shown in that image. This is the imagery. With reference to that, we are targeting a stadium. So shape refers to the external outline or geometric configuration of any object which is visible from that image. Human activities or human constructed structures generally possess regular geometric shapes just like rectangles, circles, linear patterns, etc. So here natural features usually exhibit irregular shapes and complex boundaries. So natural features are irregular, whereas the constructed features or man-made features have the distinct shapes. Element will be the size. That size represents three patterns: context and scale point of view, where absolute versus relative size we can compare. That size that must be always considered in the context of image scale, just like small, medium, large with reference to the shape or the area captured with reference to that. Here the example, the width of a line determines if it is a path, a local road or a super highway. So that size, which is just like the shade, house or factory land. So size depends the dimensions or the extent of any object, and that depends on image scale and the spatial resolutions, where the knowledge or the information of that standard object with reference to its dimension, that gives the understanding with reference to the or comparison with reference to the similar features or non-similar features. Here the large industrial buildings can be differentiated from residential ones or other like structures. Element, that is a pattern, where order versus chaos we can consider. Here two images are there: ordered pattern, which is a human image, where or human constructed image or natural non-natural image, where irregular pattern, which is a natural image. Here the pattern is a spatial arrangement of objects. Orchards and cities show geometric repetition, where forest and rivers show fractal irregularity. Means if we taking the aerial imagery of constructed or infrastructural image, then that will be the in ordered pattern. But if we considered a image of nature or any topographical condition ground, then it will be in irregular format. So pattern refers to the repetitive arrangements or distribution of objects over an area, whereas the agricultural fields, residential colonies and transportation networks are exhibit the characteristics and their patterns. So the organized and systematic arrangements generally indicate anthropogenic activities. So engineers, they use that pattern effectively to analyze for urban growth studies, land use assessment, mapping and infrastructural development point of view. Next element will be the texture, which is the frequency of tonal change. Basically here the rough texture, which shows the forest, where the smooth texture, which shows the grass or field. Here the continuation is there, here irregularities are there. So texture is produced by the aggregation of features that too small to be seen individually. For example, leaves, shadows, it is a scale dependent. So here low frequency for tonal change in the smooth texture, but as high frequency for tonal change due to light and shadow interplay in the rough texture. So texture that describes the frequency and the arrangement of tonal changes within an image, that provide the actual information encountered in that image with reference to its roughness characteristics. So here the smooth surface such as water reservoirs that exhibits fine textures, while forest gives the coarser texture or high roughness value. So civil engineering point of view, if we use that texture for the image interpretation point of view, which that includes the terrain classification, geological mapping, and identification of erosion prone regions. Next element will be the shadow, that is revealing height and relief inversions. Here we see the correct orientation, and this will be the relief inversion. So here the shadow fall toward observer, mountains appear as peaks in that image. Just we are seeing from this way. This way we are seeing. Here the relief inversion, that is the actual or vertical image taken where shadow falls away, mountains appear as valleys. So means that shadow provide a profile view revealing height, that examples bridges, towers, but obscure detail in the dark areas. That buildings, towers, trees, and bridges often produce distinguishable, or we can say that the identifiable shadows or noted shadows in satellite imagery. So shadows are formed when elevated objects obstruct incident sunlight and can reveal information about the object height and its shape also. So the excessive shadow or large shadow may obscure surface details and complicate interpretations. So civil engineer use that phenomenon or the interpretation key of shadow for analysis purpose, for the building height estimation, urban morphology, and infrastructural assessment point of view. Next element will be the site, that is the topographic and geographic logic, or we can say that the coordinates or the location, which is dependent on the topographic analysis, where we use the geographic sensors on the basis of elevation point of view. So here the actual ground profile, and with reference to that we are marking the vegetative change, soil, drainage sheet, then sewage plant likewise. So here the site refers to the specific location of objects in relation with the elevation, slope, and terrain. For example, sudden changes in vegetation often indicate that the actual change in the soil type and the drainage conditions. So that site refers to the geographic location and environmental objects with the features are commonly associated with specific topography and hydrological conditions. So here reservoirs are also located within the valleys, while industrial facilities are often situated near to the transport corridors or the highway alignments. So we have to understand the site characteristics. They are most useful by the civil engineers to selecting the suitable location for dams, highways, and urban expansion projects. Next one will be the association. Here that the company you keep means the association that describes the actual occurrence of one feature in relative to the nearby objects or the environmental conditions. So here the curved parking roads are related with reference to the screen tower. That will be the association is equal to drive minus in theater, that is ticket booth or the entrance. Just like here, these are the seating arrangement. The association which is a single feature may be a ambiguous, where the combination of features is a diagnostic or identified. Just like cooling towers plus coal piles is equal to thermal power plant. Here that association includes that the occurrence of one feature with relation to the nearby objects, where roads are commonly associated with settlements while bridges are nearer to the river crossings. That association which is useful to recognize the related feature or associated features, that improves interpretation accuracy and reduces ambiguity, or it clears the doubt also. So civil engineering point of view, that association which useful to analyze the utility mapping, transportation planning, and regional development characteristics. After that, visual image interpretation, their interpretation keys are also most important for the accelerating detection or noting the clarity. So here data is equal to based on the interpretation keys with reference to the resolution characteristics, where the sensors are analytical and filter will be the logic. So this is the actual interpretation keys, or we can say that the characteristics. On that basis we clarify the objective which is decided, or we can study the image and its characteristics. So feature type, it may be a linear feature or it may be a polygon feature. If the linear feature is be there, then it is paved or not paved. So paved, that is a roadway, or not paved, that is a trail like structure. But with reference to the polygon or aerial point of view, we give the regular shape, we check it will be constructed by the man-made activity or it will be in the natural phenomenon. So that interpretation keys are of the two types, selective keys and elimination keys. With reference to that interpretation of selective keys, we can use for matching the image to the typical examples, and for the elimination keys where we can follow the step by step dichotomous logic. Here that interpretation keys are more essential for no-wake interpreters and for mastering complex environments, so that the aerial images are to be easier to study and we can extract the data with reference to our objective selected. Next, that is the practical application with reference to the infrastructural domain, where we have to read the lines of civilization. See, the main road is there, which is a linear or parallel edges. Then there will be a building which is having the regular shape and the shadow is marked. With reference to that shadow, we check the actual height of that image. Then there are so many small arterial roads are also there. After that, in natural, this is the man-made construction infrastructural image. This will be the natural image where the river is marked with the varying width or the meandering activity with reference to some tree-like structure or some plain barren land. So the roads that are light tone, roads have the light tone, which are, with reference to that, the roads are constructed with the concrete, so they are in the light tone, or if they are constructed with the asphalt, they are in the dark tone. With the width defines category, it may be a national highway, state highway, major arterial road, sub arterial road, or district road. Likewise, with reference to building point of view, we take the regularity geometry, or with reference to the shape, shadow that reveals the profile of that building. With reference to the river point of view, if the river have the smooth texture, then tone varies with the sediments deposited. Likewise, we check the practical application with reference to infrastructural point of view also, or with reference to the natural phenomena noted with reference to the interpretation that build and natural environment through the key of visual identifiers. The case study which is related to the civil engineering point of view, here we detecting the invisible pipelines. So here the actual roadway is there and infield pipeline path which will be in the blue dotted line, where evidence noted with reference to the roadway or the soil over buried pipeline is better drained with reference to the lighter tone, just like this, which will be covered by the sand or gravel backfilling. So here vegetation stress visible along the track. So in that track, visible vegetation stress, and this will be the soil and over buried pipelines. Likewise, we analyze the completed project like 18-kilometer buried pipeline from Pantachutaru to Amberweth. The pipe itself is invisible, but the scare on the landscape reveals its location, or we can mark location for the civil engineering point of view. So data of the infrastructural analysis with reference to date, then resolution, sensor, and filter. This is all of the characteristics or interpretation keys which are utilized to identify that imagery which is considered with reference to the visual image interpretation. At the end, the evidence, or we can say that the summary point of view, the convergence of evidence, where the reliable images that will be useful for interpretation by the elements like tone, texture, shape, size, pattern, shadow, size, and association point of view. No single interpretation element is sufficient for accurate identification of any complex feature. So the combination of multiple characteristics is most important to improve the confidence and the answer of objective to recognize engineering structures and its problems identification procedure. So this approach which enhance mapping accuracy and that supports effective decision making in civil engineering domain. Here we see the final checklist which is dependent on detect, identify, analyze, and deduce. Means visual image interpretation techniques supports transportation planning, watershed management, and urban development projects, and many more civil engineering projects based on that checklist. So that satellite images which helps to identify the suitable sites for dam, reservoir, highway, industrial zones, we can use it that checklist for the selection point of view. So here That interpretation of terrain features assist in hazard assessment, landslide studies, and environmental monitoring. So, the integration or the correlation in between these all characteristics for visual image interpretation with reference to remote sensing and GIS that improves planning, monitoring, and management of civil engineering infrastructural activities. Stay tuned, guys. Happy learning.